read the question. There are a number of spherical balloons spread in two-dimensional space. For each balloon, provided the input is the start and end coordinates of the horizontal diameter. Since it is horizontal, y coordinates don't matter, and hence x coordinates of the start and end time of the diameter surface. Start is always smaller than the end, and there will be at most 10 to the power 4 balloons. An arrow can be shot up exactly vertically from different points along the x-axis. A balloon with x start and x end bursts by an arrow shot at x, and if x start is smaller or equal than x and smaller or equal than x end, there is no limit to the number of arrows that can be shot. An arrow once shot keeps traveling up indefinitely. The problem is to find the minimum number of arrows that can be shot to burst all balloons. Okay, let's visualize this example. This is the position of the x-coordinates of the balloons. Here we have several balloons from 10 to 16, 10 to 16, 2 to 8, this is 2 to 8, 1 to 6, the balloon here, and the last balloon, 7 to 12, 7 to 12. So in this example, this is what the 4 balloons look like, and we are going to shoot arrows vertically. For example, if we can shoot from 1. If we shoot from 1, then we only burst 1 balloon. If we shoot from 6, you can see here, then we can burst 2 balloons. And if we here shoot from position 11, then we can shoot the rest of the 2 balloons. So this is what the problem is going to say. So we want to minimize the number of arrows because here we have 4 balloons. We can of course shoot 4 arrows, but that is not what the problem wants. We want to find the minimum number. So what does it mean by minimizing the number of balloons? Because we can see here clearly from 2 to 6, the 2 balloons, the x coordinates overlap. So this is so we want to shoot in the overlap area as much as possible. So this is the original order of the 4 balloons. It is no order. We don't know the start time. It is not sorted by the start time or end time. In order to find the overlap area, we have to reorganize to sort the balloons in some way. So naively, we start by thinking, oh, okay, I can sort by start time. And let's see what if we can sort by the start time. Okay, here, for example, we have balloon start from 1 to 6, and we sort by start time. Then the next balloon start here, for example, at 8. So the start time 8 is later than start time 1. But what conclusion can we draw? So since the balloons are sorted by start time, then next we want to compare the end time. So balloon 1 end at position 6, and balloon 2 end at position 9. So in this case, of course, we compare the end time of the 2 balloons. We say, okay, the current balloon end time is bigger than the previous end time. So in this case, we need another arrow. But is this the truth? For example, here, if the second balloon, and also this is the case where the second balloon also end at position 9. the first balloon ends at position 6. But in this case, do we need another arrow? No, because you can see from the start time, the second balloon started at position 5. It overlaps within the 1 and the 6. So in this case, the balloon 2, the start time is bigger, the end time is still bigger, but we cannot say we need another balloon. So sort by start time is not a good it's not the right direction to go. So since we want to keep in mind, we want to find the overlap, and we need some order to these balloons. So we cannot draw any conclusion from starting by start time. Then let's try if we can find anything from start by end time. So here, suppose balloon 1 start at position 5 and position 7. And the next balloon, the current balloon, start at, since we sort by end time, then it ends at 11, for example. So here, the end, excuse me, balloon 2, the current balloon ends at a later time. So we want to know if this balloon, to burst this balloon, if we need to add another arrow. So, okay, then we start to check the start time. The balloon, in this case, balloon 2, the start time has no overlap with the previous balloon, the previous end time. So in this case, we need another arrow from here, anywhere from here, and the second arrow anywhere from here. So in another case, if the end time of the second balloon starts later, but keep in mind, its start time is within the previous interval. How do I know? Because I compare the current start time with the previous end time. And then you are able to see, okay, this is the overlap. So we find the overlap here. So the conclusion we can draw is, if we start by the end time, then if the current start time here is smaller or equivalent to the previous end time, then we are guaranteed that there is an overlap. Then since there is an overlap, then we do not need another arrow. So this is really get an example here and then try draw the conclusion by example. I don't want to just tell you sort by end time. From nowhere, you have to write an example and then come up with the theory yourself. So sort by end time, we guarantee there's overlap. Overlap means no more arrow. Okay, since we understand this, it's very easy to write the code. First, we use the lambda expression to sort the pointed array by the end time, and then keep the result in a variable, and we start from the first sorted balloon. Okay, as long we use this while loops. This while loop says as long as we are not running out of balloons, we store the end time of the previous balloon in this previous variable, and then we go on. This is the previous. Okay, then we continue our search. As long as we do not run out of balloons, we keep, and the current start time is smaller or equal to the previous end time, then that means we find an overlap, and one arrow can go through all the overlap, and so we keep searching. The condition to get out of this loop is either we reach the end of there's no more balloons to shoot, or we don't find an overlap, so we increment the result by 1. So yeah, this is this ticket. This is similar to the meeting room, but we need to sort by end time. Don't just remember the conclusion. You should memorize how I arrive at this conclusion, so you can apply to more situations. All right. Thank you. Leave me a comment if you have any questions. Thank you. How do I stop?